Hello everyone, welcome back. In this video, I would be talking about how to prepare for analog circuit design interviews for freshers. And this was one of the topic which most of you wanted me to make. So in today's video, I will try to give you a clear idea about how do you prepare for analog circuit design as a fresher and what you should know and what you need to do on daily basis to crack analog circuit design. Okay, now unlike my other videos which are usually short, this video, because I would like to explain this in detail, would be a very lengthy video. So please bear with me till the end, and I'm sure you will be benefited if you are seriously looking for analog circuit design career and as a fresher you want to get into the industry. I'm very sure these points will definitely help you. So if you are someone who are looking to make career, I'm sure you must stick to this video till the end and let me know how did you like the video. Okay, now let's not waste time and quickly start about talking about analog circuit design interview preparation. Okay, now in this video I would like to see how long it becomes so that I can divide it into two videos maybe. First I would like to talk about purely the technical stuff which we need to know or need to prepare for analog circuit design interview. Okay, so it's a very big list and that is how it is. It's definitely a very big syllabus, but I will tell you how to go about it and how you can manage time and work out. Okay, first is I'll go subject wise. First is the network theory. Okay, the network theory, the circuits involving resistors, capacitors, inductors, voltage source, current source. When I say voltage and current source, they can be dependent or they can be independent. Okay, so this is the first subject, and I'm assuming all of you who are watching this video as a fresher or someone who want to make entry into analog circuit design, you must have at least one course already completed on network theory. Okay, fine. The second is the control system, where talking where the most important topic is to know stability. Okay, how the system can become stable and what is the feedback, what is positive feedback and what is negative feedback. In the context of analog circuit design, I think stability is a very important topic and we must know it very clearly. Okay, and I will talk about this in much detail later. Now I'm just listing the subjects. The third subject which I think you must have all might have is microelectronic circuits, and this subject, the name depends on different colleges and universities, and I would like to give an view about what this subject is about. This subject actually has amplifiers, especially MOS plus BJT amplifiers. Okay, and differential amplifiers, OpAmps. Okay, so if you have at least done a course which has covered all this, uh, not much about, even if there is no much about BJT, it is fine. MOS based amplifier, common source, single stage and cascade and cascode, some idea about differential amplifier and about OpAmp. So my assumption is that you at least have had in your past these courses. I'm assuming that you have completed such courses. Okay, without having at least one such courses completed, it would be little difficult because your preparation time would be long. You will definitely require a long time to prepare if you're starting now. Having said that, it doesn't mean that you have to stop there. You can always start looking at some NPTEL videos and try to complete this first level course first. Okay, very very important. I would like to place extra importance to complete such course. But if you're someone who have some idea about what these are, okay, and you have cleared your exams on these subjects, then it's pretty good. I think I can talk about what you should prepare within this subject. Okay, now I am purely talking in terms of analog circuit design interview and what type of questions you are expected to answer. And let me start with network theory. Okay, in network theory, if you are in an interview, like would not like to name companies, if you are many big MNCs, okay, they expect you to initially the first question on the table would definitely be about RC circuits. I'm very sure most of them will start your interview with RC circuit, and I'm talking about a one-to-one interview. I am not talking about written test and all in this video. I am just covering a broader picture. So RC circuits, now again I'm going to tell you what you should prepare in RC circuit and what you need to know. First is first order of RC circuit is very important. As a fresher, I think they expect you to know what is first order RC circuit and all the different first order circuits. Okay, you need to know many things, like you need to know how the impulse response of the circuit is, how does the system respond to step input, how does the system respond to ramp input. And this anyways is not much important because I have seen, based on my personal experience, I can say that mostly they ask you to talk about impulse response and step, and among these two, step is usually asked more. Okay, so you should know what is the first order system RC circuit and what are the responses of the system. Okay, fine. And another thing is, do not I know that equations are good, you must know the equation, but also you must know what does that equation actually mean. So study in these lines. Okay, so the way in which you are studying matters the most. Remember this. Do not just remember the formula. For example, let me just to give an example. For example, very simple in this, because I'm not talking about problems and solution in this video, I'm just taking a very simple example. Let's say there is an RC circuit and there is a step input, okay, which goes from some 0 to Vx volts, and let's say there is some V 0 volts on the capacitor. Now we know what happens is ultimately this capacitor will charge to this Vx, and what will happen to this Vo after a long time? The capacitor will not have this charge VO, right? So it means this VO will die out, and eventually the C would charge to Vx. So I know what will happen to VO. VO would eventually die out. It means it will be multiplied by some dying exponential, and eventually it will reach Vx. It means it must be 1 minus e raised to t by tau, so that when t becomes infinity, this is 1. So this is how, this is just an example. Okay, you must try to capture the equation and get it into your actual circuit. So in these lines, please prepare in these lines. Don't just remember formula, it will definitely not going to help. I'm very sure about this. Okay, fine. Next, what is this is the first I would like to say, one as a second. And second thing which you need to prepare for is always s- uh, this is a very popular question, and I would like you to solve many such questions on this. Okay, first order systems, given a pulse input, the and this time, okay, t would be very less than RC, and second case is very higher than RC, where RC is the time constant of a first order system. So you should solve many such problem, all possible first order system combination of this you must solve it. Okay, and slowly as you solve more and more problem, you will definitely get that confidence that yeah, it is quite easy. I can definitely tell you that earlier when I used to plot graphs, I also used to go to equations and do all this. But slowly as we get to know the circuit, we actually know what is happening, and that is how we go. Okay, so you did not have to worry if you don't, don't lose confidence because you are at some stage now. You can always be at a better stage, which with very good preparation on daily basis. So the key is to prepare on daily basis and solve more and more problem. That is definitely the key. Okay, this is the second point, and the third point would be, among RC circuit, you must know to find out the poles and zeros of a first order system or a second order system. Second order system, okay, as far as for a fresher, I have not seen people asking more about second order system, but I will talk about some problems which they expect you to answer for second order. Okay, if I miss it out, please remind me in the comment section. Okay, how to intuitively find out poles and zeros, and also one way to find poles and zeros is definitely go and write the transfer function, get the numerator h of s, numerator by denominator. Okay, numerator function of s and denominator function of s, then this is how it goes, right? Yeah, that is one thing, but remember that looking at the circuit, you must always be able to do an inspection and directly tell, yeah, this is the pole and this is the zero. And as far as YouTube is concerned, I'm very sure there will be hundreds of videos available which will teach you how to find the poles and zeros of a system very intuitively, and by mere inspection in a fraction of few seconds you will know where is the pole and which is the dominant pole and also on. So for a fresher, I think you must know poles and zeros. Yes, writing equation, I'm not discouraging. You must also know to write equation, but you must also know to find the poles and zeros by inspection. Okay. Now, having said this, I would like to just write this, because this is not a Q&A session. I would just draw a circuit. Let's say this is some Z1. Okay, and this is my output, and there is a R and there is a C. Now the question would be something like this: is there a zero in the system, or if there is a zero, what is the zero location? Okay, so you must be able to tell the zeros or the poles just by looking at the circuit immediately. So this definitely can be learnt over time, and it is definitely not easy. It is a very simple concept, and even in I would like to make one such video where I would talk about finding the poles and zeros very intuitively, okay, without using a pen and paper and without writing complex equation. You just looking at the circuit and see, and you can tell there is a pole, there is a zero. I will definitely make one such video. Okay, otherwise I think YouTube has many such people making videos. You please go through those videos also. Fine, so this is pretty much about the RC circuit. These are the things which you must prepare really very well, and I'm going to give you the key is to solve more problems on everyday basis, at least to solve 10 to 15 problems. Okay, take a random textbook, see the RC problem and just try to solve it. If you're someone who likes to solve problem, I am pretty sure your interview will be just like a a very easy process. You will enjoy the interview process, and also you will be selected. So you always enjoy solving the circuit, and you can only enjoy solving the circuits, which I believe, if you know the concepts very clearly. And trust me, the basic underlying concepts are very simple, and I think the mistake happens because we ignore that concept and we go ahead and do some other calculation. For example, in this example, I just remember this formula and directly start go on applying. That doesn't work. Okay, so please, the concept is to the preparation. The methodology is to solve more problem, and also second important key is to understand the core basics very clearly. Write down the main points. Okay, what is the fundamental, what is the concept which I'm applying here, which concept you are applying. So write down the basic concepts, and in circuit theory the basic concepts are actually very simple, and the problems which are built on these concepts can be complex, but the basic fundamentals are really very easy. Okay, so this is one thing which you need to be prepared really well, and I think this is the first thing which every fresher must solve, and he must be very confident solving such problems. Yes, I think this is pretty much about what you can expect for a fresher in terms of RC circuit. Second about network theory is solving problems which I'm talking about a one-to-one interview. Okay, where you will not have to use calculators and all. Okay, there will be you are just using your knowledge of network theory and applying and directly telling the solution. For example, here I would say charge sharing. Charge sharing, there are many videos you will find online. What I mean by charge sharing, let's say there are two capacitors here. Okay, and initially this has some charge and this is uncharged. What happens if this is closed, how much charge gets transferred, and all such things. And we can build many circuits like this. For example, let's say there is a voltage source here and there are two capacitors. Okay. Hmm. There are two capacitors. Let's say there is a switch. Okay, initially let's say this has some charge. Immediately when the switch is closed, what is the final voltage across each of the capacitors? Such questions, which are these questions actually are really very simple, and please do not make any mistakes in such problems, and take your own time and solve it. And another important, just like these two key points which I told you, solve more problems and have good basic fundamental understanding. The third point is, initially do not hurry to solve the problem. Be very slow initially. Get the right answers. Later, as you solve more and more problem with the slow and steady pace, you will start solving it at a very high speed. So do not attempt to just get the answer very quickly and make mistakes. That is not at all the right method of learning, or this will definitely not help you in an interview. Okay, so if you are making mistake, it's okay, but you must do it slowly and get the right answers. Then build on that and increase your speed. Okay, so speed is definitely, some people think that if I solve it quickly, like this used to be my thought process also. Like I would think, if there is a problem which can be solved, which takes 2 minutes, if I solve in 1 minute, yeah, it's really great. But as in when I started learning things, it's not important. Okay, so being fast is not important. I think, definitely think this is true even in industry. Okay, what is it doesn't matter if you are slow. Okay, if you are slow, it's not a problem. The interviewer will give you sufficient time to make corrections. He will give you sufficient time and hint to arrive at the right answer. How are you arriving at the solution matters the most in the interview. Okay, how are you approaching? Correct. So remember, being fast is not at all important. Do not get into this kind of problem solving. Okay, if you are fast, it's good, but this is not expected. If you are doing it fast, really great, but no mistake, and being fast is good. But just because you want to be fast and that is how you want to prepare, I don't think that is the right way. Be slow, it's fine. Make mistakes and apply application, right application. Okay, applying the right method and arriving at the solution, step by step process is what in the industry expects. Okay, and I can definitely tell you one thing, that people who try to finish the task very fast, they would spend twice the time, 2x times, to rectify their mistakes. This happens most of the time in industry. This is what happens. So do not get into that. Do it very slowly and get the right answers. Okay, I think I have talked too much, which is out of the topic. Let's get back here. So charge sharing is another important topic which you need to know. The third in network theory is, voltage sources, current sources, the resistors, only resistors. Okay, these problems are very common. Okay, for example, I'm just drawing a random circuit. Okay, this is I'm just trying to tell you how a one-to-one interview questions looks like. For example, let's say there. See, for example, if they ask you what is the on the drop across the voltage source. Okay, but just by observation, you know that no matter what voltage this voltage source has, this current is decided by this current source, is it not? So you can directly tell the current is fixed by current source, so the voltage drop is decided by the current. So that is as simple as that. So such questions is expected for you to answer in a one-to-one interview. So for example, another thing would be, okay, now let's say there is a resistor here. Okay, does it really matter if I put a resistor here or not? Doesn't matter, right? Because the voltage at this point is fixed by this guy, let's say it is V volts. This node voltage is always V volts. Here you connect 100 ohm or 10 ohm or 10,000 ohm, it really doesn't matter. So try to identify the dummy elements in your circuit. What do I mean by dummy? the elements which doesn't matter, even if I remove it from the circuit, if it doesn't matter, so remove it. So such techniques you should know. And in such questions, the techniques which you must know are like this: trying to simplify. You must know how to simplify the circuit. Okay, how to simplify, how to reduce it, how are you reducing the circuit to even simpler block. Okay, for this I think the hint is observation. Make a very good observation of the circuit, observe it, look at it carefully, see what is happening, and look at the question, hear the question correctly. For example, if the voltage is asked, no, don't worry about all this, directly tell the answer. You don't have to write equation. Okay, fine. So observation is the key when it comes to such circuit, and the next is to simplify and reduce as much as possible, and try to use theorems, and appropriate applying the appropriate theorem is another key to solve problems like this. So you must prepare in this direction. Okay, so the third key is anyways the same. You have to solve more problems, solve many problem, at least daily, at least get 5 to 6 problem and solve them, and solve problems which do not need you to write equations initially. Okay. Okay, having said that, I am not saying that you must not know how to write equations. This is just for the interview. I'm assuming that you already know how to write the equations for a given circuit. Okay, so that's pretty much about network theory. I think if you do this much, I think it is sufficient. RC, the charging, charge sharing, and the circuits involving voltage source, current source, and capacitors, sorry, resistors, and we can also have capacitors also. Very rarely people would ask you about inductors. Okay, I have not seen many of them ask, but if it is asked, you must know the basic governing equation, and like what happens to the current and voltage equations of inductor. Okay, when does it become open and when does it become short, just like capacitor. So do not ignore this. Always it's good to have a good understanding about the inductor also. Okay, that's pretty much about the network theory. Now let's go to control theory. And this control theory will be in the context of, sorry, control systems will be in the context of analog circuit design. Okay, so what you should know is this. First is we must know the feedback system. Okay, the classic feedback system and all the different topologies like voltage sensing, voltage mixing, voltage sensing, current mixing, uh, current sensing, current mixing, current sensing, and voltage mixing. Okay, all these different four type of amplifier topologies you should know, and you should understand their feedback. And in feedback, you must, what you need to know or how you should prepare is, you must know what is R in and R out in the presence of feedback, and what happens to the gain and what happens to the bandwidth. So I think this much would be sufficient. Going ahead, I think next step would be you have to have some idea about MOS amplifiers with feedback. Solve some problems where there is MOSFET amplifiers and which has some kind of feedback. Okay, this would definitely help, and you can apply this control system knowledge over there and solve the problems easily. Okay, and another thing which I would advise as far as this is concerned is try to solve some problems on gate examination. I think this would help you really help you for analog circuit design interviews as a fresher. Okay, pick a random gate question and try to solve it. Before that, you properly understand, spend some good amount of time to clearly understand the feedback in all these four topologies. Okay, and understand what happens to these parameters, and then go to this topic. Okay, and the next thing in this control system is stability. Very important. Okay, so looking at the circuit, you must know whether the system has a positive feedback or a negative feedback, or whether it has both feedbacks. There can be system with both feedbacks also. Okay, Now for a system to be stable we need negative feedback. That is what we need to understand. And why negative feedback? You must have a very clear idea about this. Okay, so prepare in these lines. Why stability? If there is a positive feedback, what should I do? Okay, if there are both positive and negative feedback are present in the system, and if you want your system to be stable, we know that we want the system to have negative feedback. We want negative feedback, but how to make negative feedback dominant? Okay, how to make this negative feedback dominant? This is very important. Okay, uh, there will be many such questions which you can expect even as a fresher, and even for experienced people such questions are asked. For example, if you look at the circuit which is BGR, the band gap reference, it has two loops. Okay, and it has two feedback. One is positive feedback and another is negative feedback. Okay, they can draw some of BGR kind of network and ask you which is the positive and negative feedback here, and which is the dominant one. Okay, is the system stable or not? So in these lines you must be very thorough with the stability of the system. Okay, fine. Then this is pretty much about yeah, control systems. Okay, and about microelectronic circuits. Yes, let's come to microelectronic circuits. I know I'm taking a lot of time for this video, but I am sure it will definitely benefit many of you. So I'm not hurrying and making this video short. This video would be a longest video I think in my entire list of videos. So microelectronic circuits start with understanding the MOS. First study the VTH. Okay, I would like to spend some time to talk about VTH. See, I can tell you very surely that VTH can be modeled. I know you can remember the equation here also, but in we must be able to view VTH in the light of the device physics. Okay, what happens to VTH? For example, if the bulk to source is increased or decreased, what will happen to VTH if the let's say the temperature is increased or decreased? What will happen to VTH if let's say the charge in the depletion region is increasing, decreasing? Okay, so you must know what is VTH, how the what is VTH actually means, and which are the parameter which changes the value of VTH. Very important, very important. Okay, for example, I will just talk about one problem here. This is asked usually in the industry. Let's say this is a common CS, and this is a bulk. Okay, and the bulk voltage is varied. Okay, if this bulk is connected some voltage, if I vary this bulk, so what is the current, how does it change? So such questions can be easily asked. If you look at this question, it looks so simple, right? Just a common source and bulk is being changed, what will happen to the current? So you can, just by looking at this you can say what happens to the current, and by knowing what happens to VTH and what is happening to the current. Okay, fine. So very good understanding on VTH. Spend good amount of time, and do not always look for short videos. Okay, see, there are many videos which can be short, but I am very sure short videos are like reviews. Okay, assuming that you have some basic idea about VTH. But when you are learning the concept for the first time, I would advise you to look at big videos which has more explanation, like something from NPTEL, and then come back to shorter videos which will tell you, ah, yeah, this is what it is. Okay, you are just summarizing your understanding, or making your understanding more concrete. Okay, fine. So that's about VTH. That would be the first thing. Then understanding the IV characteristics of a MOSFET, the region of operation, linear saturation, cutoff, and all that. Fine. And okay, here also you would be given, talking about linear saturation and cutoff, you would be given circuits where like you would be given the value here, you will be given a value here. Okay, you must talk about which region it operates. There can be any circuit like this, whatever. you must be able to talk about its region of operation. Okay, and you must also be able to plot the IV characteristics, the IGS, VGS. Okay, fine. Then let me talk about the most important topic here is amplifiers. The single stage amplifiers, the common source, the common drain, common gate, the cascade and cascode. All these amplifiers you need to know very detailed. And here for every amplifiers, I think the best reference for this is to go for a book by Behzad Razavi and try to solve more problems for this book. It is if you solve problems from this book, I'm very sure the confidence level would be very high, because the problem in Razavi is really, they are really they are really testing, they really test if you know the concept properly. And there are many problems which I myself cannot solve them even after knowing the concepts. So there are many complex problems there, so you can test your understanding by solving problems from Razavi. Okay, here what you must learn is, and what you must pay attention is, you must be able to find out the GM. Let me not write small gm, the capital GM and capital R out. You must be able to find out this. Okay, just by looking at the circuit you must know whether the GM is increased in the circuit or decreased in the circuit, whether the R out has increased or decreased. You must know this. Just look at the circuit and what will happen. Okay, fine. For example, let me take this. This is a common source amplifier with source degeneration. What would happen to the GM of the circuit, whether it is increasing or decreasing? Okay, what will happen to the R out looking down, increased or decreased? What has happened to the gain of the system, whether it has increased or decreased? Okay, just by adding this RS, what are the impact on GM? What is the impact on R out? What is the impact on AV? Okay, such questions are really asked. And some questions are very tricky questions, like there is a current source and there is a MOS and there is a current, there is a resistor. What is the gain over here? Okay, such questions are very simple. I can tell you this, you will find such questions on YouTube and many places. They are very simple, and by looking at that they look complex, but if you know what is happening you can easily comment. Okay, another important thing is, please always here, even though I've been telling don't remember equations and all, for this amplifiers it's good that you remember them, and there is one way to remember them just by looking at circuit. But remember some standard equations so that we can build on that. Okay, only for amplifiers I'm talking about. Okay, like you must know what is the gain of an amplifier for common source, common gate, common drain, and what is the input resistance like, output resistance like. Okay, about these two you will definitely have some questions in the interview, so prepare very thoroughly. For example, they will draw a random circuit like this. Okay, this is some bulk, and like this they will ask you what is the resistance looking downward, and another thing can be like this, what is the resistance looking downward here. Okay, many such circuits can be asked. So here, if you know how to work it out, it is easy, you can solve it. But some problems, okay, may require you to write equations, and I think many such problems can be solved very easily. Okay, we can solve it, and it is purely based on experience. You solve more and more problem, that will become easy. Fine, so these are very important. This is one thing which they will ask you, and they will ask you to derive also sometimes. And they expect you another thing, I could say, let's say there is a cascode. They will ask you, if there is a voltage change here, how much of this voltage change will appear here at this node, how much of this will appear here, such questions. Okay, so prepare on these lines very thoroughly. So that's about the single stage amplifier. The last part would be OpAmps. This is really a big topic. I don't know how much. I definitely need more time to talk about this, because there are many things about OpAmp. Okay, so what exactly is asked in the OpAmp, I would like to make a different video. Okay, we will make a different video, because by OpAmp itself is a very big topic. I think I cannot cover this in this particular video, and this would become a very long video. If you're interested to really understand the questions for which are asked in OpAmp, and as a fresher I assume that there are not much questions, but if you have worked on OpAmps they will definitely have more and more questions. Okay, and I will talk about this in a separate video, all the questions which you can expect or what you should prepare and how you should prepare for OpAmps. In this video I would like to talk about OpAmp circuits like adders, subtractors, integrators and differentiators. And integrator differentiator, there are two. One is ideal integrators and another is practical integrators. You should know how what are the circuit and how it works. Here you must know to write the transfer equation. You must be able to do the Bode plot, and also by intuition or by inspection you must be able to find out the poles and zeros of a system for all this circuit, especially for I'm talking about these two, integrator and differentiator. You must be able to do this. Okay, and in op-amps you can have questions like there is a op-amp and there are, I'm not drawing the actual circuit, there can be some xyz, something over here, and there is another feedback here and some load over here. Okay, let's not get into that. Let's say there is two feedback and you have to find out which is dominant and how will you make it stable and all such things. Okay, so let it be something like this. What I'm trying to say is there will be op-amp which has both feedbacks, negative as well as positive. So what is dominant, how will you find it? So you must learn in this particular lines. So be thorough with op-amps with feedback, they are very important. Okay, yeah, that's pretty much about that. I hope I've covered almost all the topics which you need to understand. Yeah, for any, if you have any particular question, I hope I have tried to give you an entire view about what is happening or what are the topics which you need to concentrate on how to prepare. And yeah, you can always drop your comments if you think you want me to talk more about any particular topic. You precisely explain me what exactly you want me to talk about, so that I can make another video talking about those topics. Okay, and as far as your preparation is concerned, I would like you to spend more time solving more and more problem. And my one quick advice would be to make short groups with your friends, at least a group of 5 to 10 of interested students. They can be your friends or someone who is interested in making analog circuit design career. Make a WhatsApp group or any group. You must share problems and solve it in the group. For example, let's say there are 10 people, and you, if 10 people solve one problem, at the end of the day you will learn 10 different problems with solutions. So that is how you can increase the speed of your problem solving. So always do group discussion, debate with your friends and see whether it is right or wrong. Okay, I am looking forward to make such groups in future, but as of now, because I am not able to spend more time, this has been a little difficult task. So please make groups on your own and try to actively contribute in that group, share problems, try to solve it, discuss about your problem. Okay, and verify your answers. That is how you can really learn quickly. Fine, I think I have pretty much made the points which I had decided to make. If still you have any question, please drop it in the comments. I hope this video was helpful. Please subscribe to support making of many such videos.